Review question. When do you flip the inequality sign? The only time you flip it is when you multiply or divide by a negative number. Today is 5-2 multi-step inequalities, day 1. Again, it's okay to pause anytime that you need to stop and catch up. So far we solved simple inequalities, 1 and 2 steps. But in Unit 2 we solved more extensive equations. Like this one, where it was 3 times the quantity of 4x plus 2 equals 10x minus 20. Today, we're going to do the same thing with inequalities. We're going to learn how to solve the more difficult equations, or the more difficult inequalities, like we did the equations. Today's objective, you will be able to solve a multi-step inequality. Now some of these are only going to have like 3 steps. Others will have 4 or 5 steps. It all depends on the problem. I'm also going to want you to graph them too. So it's important to go back to that Unit 2, and if you struggled on that, to look over those notes so that you know what you should do for this. First example is example 1. In example 1, it says solve and then graph. So let me just move this over a little bit. Okay, the first thing we want to do is get our x's on the same side of the inequality. Don't forget you can draw a line through the inequality so you know what you have to cross over. So I'm going to subtract the 6x to the other side. The reason I subtract is because I don't want to end up with a negative. It gives me 2x plus 10 is greater than negative 20. Now, in order to get x by itself, remember that's your objective here, we have to subtract the 10 to the other side. Those cancel, you get 2x is greater than negative 30. Oops. Now, final step is we divide by 2. Negative 30 divided by 2 gives us x is greater than negative 15. Now remember, you don't flip the sign because we didn't divide by a negative. Even though it was a negative divided by a number, we did not divide by a negative. So your sign stays the same, or your inequality. When we graph it, it's 0, negative 15, open circle, and it's all the numbers greater than negative 15. So everything to the right. Fairly simple. Example 2. The first thing you have to do with this one is distribute the 3. That gives you 3x plus 18 plus 2x is less than 5x plus 12. Now I remember from Unit 2, one of the most common mistakes I saw was people would do minus 2x here and minus 2x here. That is not true. Remember, you only subtract when you're crossing over the sign. So that's why we might want to draw a line. So we only subtract when we're crossing over the inequality, which means 3x plus 2x, we just combine those like terms. That gives us 5x. So it's 5x plus 18 is less than 5x plus 12. Now you have to get your x's on the same side. So we're going to subtract 5x from both sides. Those cancel. You're left with 18 is less than 12. Now, what's the problem here? When is 18 ever less than 12? So now we're going to look at a new type of solution. 18 less than 12? Never. What does that answer mean? That answer means that there is no solution because 18 cannot be less than 12. How could it be all reals? It would be all reals if it came down to the end and it was 18 greater than 12. So when is 18 greater than 12? Always. So that's when it would be all real numbers. When your x's disappear and all you have left is two numbers and it makes a true statement. How would we graph no solution? We can't. All real numbers would just be shading everything above the line. And so if you get all real numbers and no solution, I wouldn't expect you to graph. Example 3. If we solve this one and then graph it, first we have to distribute this negative to both terms. So that's going to give us 8x minus 2x minus 4 is less than or equal to 4x plus 10. Then 8x minus 2x gives you 6x. Remember, we didn't cross over the line, we're just combining those two. 6x minus 4 is less than or equal to 4x plus 10. Now I'm going to subtract 4x from both sides. That gives 2x minus 4 is less than or equal to 10. Add 4 to both sides. You get 2x is less than or equal to 14. Divide by 2, x is less than or equal to 7. Whenever we graph this, 0 and 7, because it has the equal sign underneath it, it's a closed dot, and then it's less than, so it's shading to the left. Now it's time for the U-tries. I want you to try all 4 of these, and then I will go over them. So pause the video so that you can try them on your own, and then we'll go over them. Okay, number 1, let's solve it. I'm going to draw my line. Actually, I'm going to move it all around. Now I'm going to draw my line. Start by subtracting 2x. I'll give you 2x plus 12 is greater than 24. Subtract the 12. You get 2x is greater than 12. Divide by 2. X is greater than 6. When we graph it, 0, 6, open circle because it's greater than, no equal sign, and then it's all the numbers bigger than 6. That should be your final answer. Number 2, draw a line in, distribute the 5. 5 times 2x gives you 10x plus 50. On this side, the 15x just stays the same. So 15x is less than or equal to 10x plus 50. Now get your x's together. It's never a good idea in real life to get your x's together. It gives you 5x is less than or equal to 50. Divide by 5. X is less than or equal to 10. Close circle because of the equal sign. And then shade to the left because it's all the numbers less than 10. Number 3. Drew the line in. Got to distribute this negative first. So it's going to give you 2x minus x plus 5. It's greater than or equal to 2x plus 17. Now 2x minus x just gives you x plus 5 is greater than or equal to 2x plus 17. Subtract the x over. Gives me 5 is greater than or equal to x plus 17. And subtract the 17 over. You get negative 12 is greater than or equal to x. Now, this is one of the questions that I see people get stumped on a lot. And the reason they get stumped is because the x is on the right-hand side. Make sure that you always get your x to the left-hand side at the end. So you want to flip this whole thing over. X. The arrow is pointing towards the x right now. Make sure your arrow still points towards the x. Is less than or equal to negative 12. That's the same thing as saying negative 12 is greater than or equal to x. If we think about it this way, if I have $10 and Micah has $1, then $10 is greater than or equal to $1. Well, it's greater than $1, right? That's the same thing as saying $1 is less than or equal to $10. So I still got more money than Micah. Either way. But just as a whole, we like to see it in this form because you know which direction the arrow points now. It's a closed circle, and then it's everything less than. Number 4, distribute the 3 first. That gives you 6x plus 6 is greater than 6x minus 4. Now automatically, as soon as I see that these numbers are the same, there's no other x's in the problem, I know that I can cross those out. But I'll do it the long way anyways. Subtract 6x from both sides. Now they cancel out anyways. It gives you 6 is greater than negative 4. Is 6 greater than negative 4? Yes. So your answer is all real numbers. Okay, I hope you find this helpful. Remember, you can always email me if you have any questions or need any help. All right, guys, keep up the good work.